Hi everyone. We'll just give 2 minutes for people to join in. We have around 10 attendees. Has anyone attended a Geek Night before? You can raise your hand if you want to speak. Hi Priya. Do you want to share your experience?
Yes, actually, I've attended only one geek night, which was for contract testing.
Mm-hmm.
So it was not nice experience because the person who was giving, they went through all the theory section as well as the practice, and then we had some little quiz as well around that.
Nice.
So it was interesting actually.
Oh, nice. So which location was it from? The Geek Night?
Gurgaon, I think. Gurgaon or Chennai? I don't remember exactly because it
Okay.
was happened, and right now we are getting all the mails from Chennai as well as Gurgaon. So I don't remember exactly from which location it was.
Okay. Sure. Do you have any expectations for today? Like, what do you have anything specific you're looking for?
So specifically, I am interested in securing the containers because I don't have much experience on containers, and right now we are working in containerized application.
Mhm.
So I'm more looking into that session that
Nice,
I'm
nice.
be able to aware that how I can do those things and what would be the good best practices which I can achieve.
Yes. I think you'll definitely get it covered from Tanmaya. Nice to talk. Nice talking to you, Priya. Anyone else have attended a Geek Night before? It's 5-2. We'll just give 30 more seconds for people to join. Okay, then we'll get started. We have 18 attendees. I think as the talk start, we'll have more attendees. Anyway, hi everyone. I'm Pujita. I'm a developer in ThoughtWorks. Welcome to Geek Night. This is the very first edition of Geek Night in 2021. So I welcome you all. So Geek Night is a platform where tech geeks come together to share, to discuss, and also to learn technology. And this is something ThoughtWorks believes in, and it is sponsored and organized by ThoughtWorks as well. And for today, we have some exciting talks lined up. I'll quickly take you all through the agenda for the day. So we have a talk on Git Inside Out by Chandan. It's for about 40 minutes. And then we'll take a quick break, followed by another talk on secured containers by Tanmaya. So this is the agenda and a few ground rules so that we can make this talk more efficient. Or since it's a webinar, we let's keep it more casual. Let's have more lively discussions. To do that, let's follow some Zoom features at least. Like there is a Q&A section on the bottom right of your screen. So during the talk, you can make use of that. You can ask your questions and the speaker will take some logical pauses and answer your questions. And after every talk, there will also be a Q&A session. Please do make use of them. There you can raise your hand that will allow you to talk so you can ask your question directly to the speaker. And also at the end of the session or end of the event, we'll have a survey, which is mostly we would like to collect some feedback on how the event was, the organizing, and also if you have any feedback for the speakers, it would be really valuable. So please make use of all these tools that we have in hand to make this webinar a useful one. Without any further ado, let's get started with the event. For the first session, we have Chandan, who will be speaking about Git inside out, something very interesting, like we use Git on our day-to-day life, but learning a bit more insights about it, we'll hear from Chandan then. So Chandan is a thought worker who has more than around 3.5 years of experience. So over to you, Chandan. Maybe you can describe or introduce a bit more about yourself.
Thank you, Pujita, for kicking this started and introducing. So I'll not waste your time and I'll quickly share my screen and maybe we can directly get started. So as Pujita already introduced, I'm Chandan, working as application dev in ThoughtWorks. So, and today's topic is knowing Git inside out. It will be mostly around internal workings of how Git internally works and what it does internally to do whatever we do in the our day-to-day life. So let's get started with the agenda. So agenda is pretty straightforward. We'll be briefly talking about what is Git and we'll be exploring what inside.git, and then we will be understanding what are Git objects, which are also called Git databases. And then we'll be talking about types of Git commands, not the commands which we use in our day-to-day life, but more of an internal command. And then we'll be creating a hands-on demo of creating a Git repository from scratch without using the git init command. And we'll be and that part included, we'll be talking about how Git branches work in turn. So I'm assuming you already know Git on a top level and you use Git in your day-to-day life. You are making Git commits, making Git push, and making branches already. So that's kind of prerequisite for this session. You already know some part of it. If you don't know, also it will be kind of explore about like how Git works. So if I had to explain you about what is Git in a brief manner, Git is a version control system. So it helps you manage your code versions and anything you want. So for example, many of us in colleges or school days, in while creating our projects, we used to have these files kind of project and then version 2 of project, and then we used to say this final project. So that's kind of a version controlling that we used to do to manage our versions of the project. So it makes our life easy to know which is our final project and which is the initial draft which we have created. So that's also kind of a version control system. But what Git does it helps you manage things very efficiently, and internal work it does for you. So you need not to worry about the internals, but you can manage your version so easily. So Git is just a version control system, or you can also call it as intelligent file system, which helps you let manage your versions. So these are the popular version control along with the Git, which are popularly used. So we mainly hear about Git only, but there are other version control systems in the market that other peoples are also using, kind of subversion, and these are the icons. I don't know about all of them, but we'll be mostly talking about Git in this session. So the first question comes here is why should we even worry about knowing internals? So even if you don't know the internals, I'm very sure we can do all of the daily work that we are doing. And even if we don't know the internal, we can very easily manage all our daily concerns, and we can go ahead with the Git. But why should we even worry about knowing internals? So the thing is, as a developer, we should be aware about the tools that we are using in our day-to-day life, especially when we use it very frequently. And Git is a tool that we use very frequent. And second thing is, it really helps us managing any conflicts or any Git issues that may come around. Maybe your teammate may get into an issue with Git, So managing and solving that kind of conflict will be much easier if you know the internals better. Last thing is it's cool. I feel it's cool knowing internals of anything, but you can see if it's cool for you or not. Let's dive into Git. So what's inside .git folder? So whenever you create a new Git folder, you do Git in it. You see there are some files and folder inside your .git directory. So you see their headline, their objects, ref set, hooks. So these are some kind of files which are there. So there may be other files also, but we will not be talking about them because these are kind of main core parts of Git. So is a file which keeps a reference. Head is a file which keeps a reference to your current working directory, correct current working branch, and objects are also referred in Git as a database. So object has all the core parts and all the file snapshot which you have created and added to your Git object. So this is also kind of called as a Git database. Ref heads are used for managing your branches, and all the branches that you create lies under your ref head folder. Hooks, you may already be knowing that you can add your shell script which you can run before committing or before pushing, also known as pre-push and pre-commit hooks. And let's explore more about what are Git objects, because going further when we go to demo part, it will be very important that we understand Git objects better. So there are three kinds of Git objects inside our Git. First is Blob. So Blob is nothing but content of file without any metadata. So how it is different from a typical file. So in a typical file, we do have some metadata also. When I say metadata, which means when it gets created, who has created that, it contains data about that. But Blob doesn't have any of that. It does have only the data of content of whatever you are writing to it. So it doesn't have any metadata about it. So who has created that and all. So how do we manage that problem of not having any file name associated with that? So tree solves that problem, and tree is kind of a equivalent to a folder structure in Git. So tree keeps a reference to blocks, and in turn, it also keeps reference to other trees. So it's like folder structure. So a folder can have multiple folders and files, as you already know. And then last comes as commit. Commit is a snapshot your working tree. So every time you make a commit, it makes a snapshot of your working tree and saves it in your database. So commit is a snapshot of your working tree. And if we have to imagine that in a like visual flow, you can see on the right side that we have two blocks which has content. One has hello world as content and other has hello march as content. And on the middle, you can see there is a tree which keeps a reference to both the blocks, and you can also see the file names over there. So now we know that hello world resides under a file which is called foo.txt, and bar is lying bar.txt contains hello march as a text. And the top left side, you can also see that there is other tree which keeps a reference to another tree and a blob. So you can also assume, like, visualize it as a folder structure where one folder has another folder which has a file, and then there are two files inside the nested folder. So you see here all these things are like referenced with the SHA-1 ID, which are shortly named as we can short also the SHA IDs. For example, here 2F3A is a SHA ID for that. So we'll be talking more of them in when we go to hands-on demo. So let's jump to the next slide. So there are two kinds of main commands which we use in Git. So one is a porcelain command, which are kind of low-level commands which Git used internally to do whatever it does internally. And then there are commands which are called plumbing commands, which we use in our day-to-day life, like git commit and all. These are those commands. Now let's create a repository from scratch and see how we can create a repository from scratch. Let me just jump to my terminal. Just can anyone please confirm if you can see my terminal?
Yeah, we can see each other.
Yeah, thank you for confirmation. Uh, let's now we till here. If we have any questions, do we have any questions in chat
No, we
or
don't have. We
Q&A?
can
No.
move ahead.
Okay, then I can proceed with the demo. So whenever we want to create a Git repository, what we do initially, we do a Git init. So whenever we do a Git init, we can see that there is a .git directory which gets created. So in the Git directory, you can see there is a head, there is a config, hooks, objects, and refs. You can see different values depending on your Git version. But these are these head, hooks, objects will be the common parts you will see everywhere. So let's jump and see what's inside our head part. So let's cat inside head, and you see that our head has a reference to master, and master is nothing but our current branch. And you see that head has the reference to the current branch. And objects has two folder, info and pack. Will go inside that in coming section. And we also have this ref section. Ref has a head and tag. So currently we don't have any commit. So if I do a git log, I can see that there is no commit lying there. So if I had to make a commit here, I'll simply say echo, let's say git is cool. And then I'll put this into a file called foo.txt. And then if I had to do a git status, it says that you have a file which you can commit. I'll add this file to git. And now you can see an interesting part over the right side. It created a file inside this objects folder. So let's see what is this. So you can see that it is a 40 character SHA which is divided into two parts. First two characters are the folder names and rest are the file names. So as I already talked about, Git has three kinds of objects. Let's see what kind of object this is. So if I had to see the content and the type of this file, Git gives the internal command, which is called git cat file. And cat file takes a SHA-ID as the input, and the SHA-ID here is 15, which is a folder name, and plus 38 character of file name. And then if I had to see the type, I can say git cat file -t and the SHA-ID. And you can see that the type is blob, the first type which we have expected. So this is a blob, and if I had to see content of this file, I can simply say -p. So this is a different kind of file. If I'll do simple cat over this file, you can see only random numbers overlying there. But to see the actual content, we can use these git internal command, which can show you the content. So once I do a cat file of this SHA-ID, I can see the content over inside this. So this is the same content which I added there. So now I'm at a good place to make a commit. So now let's make a commit by saying first commit. And now we can see that in the right side, it has created two more objects, and it has a commit ID also. So let's see what are these two new objects which it has created. So let's go over the first one and do a git cat file, and I'll drop it down git cat file and the SHA-ID and it for the folder name. And you see that this is a commit object, and if I had to see the type, I'll say git cat file -t, and you can see the type is commit. And there is another object which gets created, and let's see the type of that. Mhm. And you see the type of other one is tree. So now we have seen all the three parts of the blob. One is tree, one is blob, and one is commit. So let's see what's inside the tree, and then we'll jump over the what's inside this commit object. We will be exploring this more, but before that, let's just see what's inside this tree object. So you can see that it has a reference. This is a file type. So let's ignore the first part as of now. But you can see this has a blob in the reference and later the SHA ID and the file name as in reference. So this means that it has a file, this tree has a blob as a reference, which is a file called foo.txt. And if we had to see what's inside the commit, I can simply say this thing and shiny. And you can see that this commit has a tree. So as I already explained, commit is nothing but a snapshot of working tree. So this has a tree and the metadata, which is also author name and commit message, whatever you are giving to it. So as you already seen, like how we create it manually using git command. So let's just delete everything and create this repository from scratch. I hope this creating from git command is clear to all. If there are no questions, so I'll be removing all of the content which are there. So first is removing this foo bar and then removing our git folder. So now we are on the clean slate. So we see that on the right side we don't have anything over there. So as we already seen that Git has three four more main files and folders which it has to be there in order to make it a Git folder. So let's just create them manually. So if I had to create a Git folder manually, first I'll say make directory Git, and then let's create an object folder and a ref folder over there. And now if let's see if git is happy with those two commands. I'll do git status. Now you see that git is not pretty happy about these commands because it says this is not a git directory. So what left here? So we also seen that refs has something called head. So let's create that header also. And now we have this head also. And also on the right side, you see now this looks like git, which has a folder, objects, and another folder ref, which has head. But we see that previously it also had a uh, file which was called head. So let's add that also. Now we see it looks pretty like some bit of similar to the actual thing which we had in when we did the git init. But if I had to do a git status again, it still says that this is not a git directory. So what else remains to make it a git repository? So when we cat this head file previously, we have seen that it has a reference to the current working branch. So Git has to know which is the current branch I'm working on. So to let Git know what current branch I'm working on, we'll have to uh, make it understand that this this is the master branch. This is the current master branch which you are working at, and assign this reference to this head file. Now you see some interesting thing here. If I have to do git status, now git seems to be a bit happy, and it says you are on a branch master and you have no commit and nothing to commit. So now Git knows that I'm on a branch called master and I have nothing to commit. So let's make a commit without using any of the Git top level commands likely to be git add or git commit. So we'll be using some commands which are called git hash object and git write update tree. So those will be commands we will be using over here. So now at this point, Git knows that the current branch is master because we have given this ref headmaster in our .git head file. So using this file, Git is knowing that this is the current branch I'm working on. So let's create a file. Again, the content I'll be taking as same, it is cool, and now I'll not write it in directly in the file. Instead, what I'll say is git hash object, and then I'll say take it from the std in and write it to our git directory. So once I do that, and you can now assume git as a key value pair. For this content, git has returned me a key, which is a SHA-ID 40 character. And on the right side, you can see that in the Git objects folder, we have a folder called 15, and inside that we have a 38 character file name. And the SHA ID which it has written, you can see that the 15 is nothing but the first two character of the SHA ID. And if I had to see the type of this SHA ID, I can say git cat file and then -t and the SHA ID. So you can see this is a blob which is created. And if I had to see the content, this is the content of the file. And now, as we already know that once we create a file, we need to add it into Git staging area, also called as Git indexing area. So we have created this blob, but we haven't added this to the our staging or indexing area. So to add that, we'll use another Git command, which is git update index. And then what it takes is a SHA ID, and you can see this command. Just let's just go through the command git update index -add and -cache info. Cache info is nothing but the file type which we are using, and this is the file type. We'll not be worrying about more about this file type as of now, but this is the file type. Let's say you want to add some executable or normal file. This is just the file type which we are giving these numbers. And now we want to add this to the ID. We want to add to Git staging area. And now we give that, and we say that this is a foo.txt. And when I say that and do git status, you can see that it thinks that we already have this file foo.txt, but we have deleted because in our file structure, we don't have a file called foo.txt. And I have added this file to Git. So that's because it thinks that it was having a foo.txt, but I have deleted it. So to solve this problem, I'll use the git cat file command, and then I will append this file to foo.txt. And now if I had to do git status, you can see that this is in the staging area, and I can commit this. And to commit this, now I'm in a committable stage because I have created a file and added to Git staging area. And after staging to Git, I can make a commit. So to make a commit, I'll have to have a tree because commit is nothing but a snapshot of working tree. So before creating a commit, we'll need to have a tree. And to create a tree, we'll use another Git command, which is write tree. So write tree will does nothing, but it will create a snapshot of your staging area. So whatever you have staged in a staging area, it will create a tree out of that. So once I do that, you can see in the right side, it has created another thing inside our objects folder and returned me a SHA ID for that. And if I had to see the type of this SHA ID, I'll do again git cat file. This is the same command we'll be using, and -t for type. And you can see this is the tree type. And this is a tree, and let's see what's inside this tree. This tree has a reference to this blob, which is which contains a file called foo.txt. Now we have a working tree, and we can commit this working tree. And to commit this working tree, we'll use another git commit command, which is git commit. One second, just see git right tree commit tree. So we'll use a command called commit tree, which takes a tree ID and a message and creates a commit on top of that. So let's just create this. So our working tree ID is this thing, which it has already done. So we'll write this tree, git commit tree, and then commit tree ID, and then a message. This looks pretty similar to our git commit command, which takes a commit message and commits it. So I'll say it as a first commit. And you see it has returned me SHA ID again and created another object inside our git object folder. Now for the final type, we are going to see what's the type of this thing. And we can see that this is a commit type. And if we have to see the content, we'll use -p, which is pretty print. And if we can see that it has made a commit with that tree having author name and committer with the message, which whatever I have provided. So we have made a commit using all the internal commands without using anything else other than internal commands. And I hope this should be clear. Do we have any questions till this point? If we have, it's better to clarify before going forward.
Yeah, there are some questions in the Q&A. The first one says, what happens to the structure when you make a new version of the file? Is it something you're going to cover next?
So just to reiterate the question, the question is when I create a food.txt and added a content over there, and then I change the content of that file and create another thing. So what happens to the object, right? This is the question that I'm assuming. So what happens there is it creates a new SHA-ID because how the SHA-ID works here is it takes your content and based on that there is an algorithm called SHA-1 and it applies the SHA-1 algorithm and generates the 40 character SHA for you. So whenever you change the content, let's say you added a space or write 100 lines of it, so it will generate a new SHA-ID and which you need to again add to Git to make that. So yes, it changes. What's the other question?
Sure. So the next one is on some examples of porcelain commands.
Okay, so these which we are using, so so internal commands. So let's say let's get so there were two kinds of command which we were using. One was plumping, which was more user friendly command, which we see that git commit, git add. These were like more of a user friendly command. And these command which you see git cat file, git hash object, those are the internal commands that git uses. I hope that clarifies the
Yeah.
command which
If
I use.
Yeah, sure. No, I was just telling if the question is something else, please do raise your hand. We can take it after the session as well.
Yeah, sure.
And there is one more question on the theme which you are using on your JSH terminal.
Okay. So I actually forgot the name, but it is I don't remember actually, but I'll surely ping you at the last.
Sure, sure. Yeah,
So
we can do that.
so so till this point, we have created a commit using all the internal commands as of now. And on the right side, we see a structure where we have all the three kinds of Git objects. So we have something here. So we have seen we have made commit. So let's see if Git understand we have made a commit. So to see any commit, we do a Git log. So let me do a Git log. And interestingly, it says that my current branch doesn't have any commits. So why does it say that my current branch doesn't have any commit? Because current branch doesn't know of this commit simply. So what happens here is our git refs folder has a head inside it. So this head contains a file which is nothing but a branch name which has a reference to this commit. And by using it, Git identifies the commit. For example, if I had to show that this is a commit ID which we have, and let's just write it into a file in our git refs folder, refs, and then head, and then my current branch is master. So now I have a file called master inside my refs head folder. So I had to cat that file, refs head and master. You see, this has a reference, this has content as my commit ID. Now, if I do git log, now it understands that my branch is a reference to this commit, and then it picks up commits over there. So interesting part will come here when I make another commit. Does Git will understand if I make another commit on top of it. So let's just quickly make another commit. I'll say that Git is much cool, and then I'll write it again, and then I'll take the SHA ID, and then I'll update it into Git. And then I'll need a different SHA ID, which is this one, which Git has just provided me, and I'll also rename the file. I'll say this as bar.txt. And then if I had to git status, I see that bar, it again thinks that I had a file called bar.txt, but I have deleted. So let's just create that file again using this SHA ID. git cat file -p this id, and I'll assign this into bar.txt. Now if I do git status, I can see this file. So now as this is inside my staging area, I can write the tree, git write tree, and then it has returned me a tree, and with that tree I can make a commit, git uh, commit tree, and my commit id or tree id, and then I'll say this is my second commit. And interestingly, it also take one more thing which is called parent. So if you see the commit carefully when in your local repositories and all, because currently I have only one commit, so it doesn't have a parent. But I had to, if I had to link commit, so I'll have to provide a parent commit ID also. So this is our parent commit ID. Let's say if we don't provide it as of now and make it, so Git will have no idea that this is the reference commit to over it. So these are two different commits which are having no connection. So these are just individual commits which we can refer, but this will not come inside chain. So that's the reason we'll need to provide a parent also, so that it can know which is the previous commit it has to go to. So this is the parent commit which I have provided. And now you can see that it has created another commit. And if I had to cat this again, git cat file -p, and then this commit ID, you can see that this is the commit which has a parent. So you can see this parent as interesting thing. And now as I made second commit, git, if I do git log, it should show me the two commits. Let's do git log. And interestingly, we see only one commit over here. And why is the reason? Reason is because if I have to cat the file, it is the first commit reference, not the second one. So that's the reason it's not able to find that one. So let's just move our branch to next commit and say that now our branch will have this commit. Now, if you see something is cleaner here, and if I had to do git log, now you can see there are two commits, and head points to master, and master has a commit, and commit has a parent commit. So this is the chain which is being made here. So I hope this is clear, and how it is referring to the parent. So if we don't have a question at this rate, I can continue and tell more about branches, how branches works in turn. So I don't see any Q&A question. So I'll just continue and see about branches. So as we have already seen that our branches are nothing but a reference to named commit. So in an ideal world, if humans are able to understand all the SHA-IDs and remember, we don't even need that branch name, because humans are not that capable of understanding this and or remembering the SHA-IDs. We need this branch names, which are more of a user friendly for end user. And using this branch names, we can easily refer to all of the things. So let's assume I have to create another branch which has these. Uh, let's say if I in an ideal world on using top level command, I'll have to do git checkout, and then I'll have to give the branch name -b and the branch name. So it will create a new branch for me, new branch, and it will create a new branch for me, no problem. But if I have to create it like that, we already seen that this ref had contain one file, and which is nothing but a branch name. So let's create a new file so that we can create a new branch. And let's just create that echo. I'll say echo, and I'll say this is a new branch, and I'll add this to my .git ref head, and now I'll say this as a new branch. Or I don't even say that. I'll just say just create a file, and this will be new branch, and it has there. But our current branch didn't move from there. If I have to do git status, I can see master is my current branch. So if I have to move to the new branch, I'll have to rename whatever resides inside this head folder. So let's just go to head file, and then rename this. And now this is my new branch. And let's just save it. Now you can see if I do a git status, it says, it doesn't say here, but you can see here that new branch is my current working branch. And if I had to do git log, you see that it says our current branch doesn't have any commit and it seems to be broken. Why? Because it doesn't have a reference to that commit. So if I will assign this commit to my new branch. I'll echo this and add it to my new branch. And now you see something is much cleaner here. And now if I do git log, you can see both the commits line here because now my new branch has a reference to this commit and parent commit you already seen that. So this is that's all for the demo purposes. And now let's go to the slide. If I don't see any open question in the chat over here. So I'll share my screen again for my slides. Yeah. So thank you all for this session. I hope this helps you understand it a little bit better. So do we have any questions? If not, I'm done with the session.
Folks, you can raise your hand. We'll unmute you so you can ask your questions. Looks like we don't have any questions, Chandan.
Yeah, sure. Then I'll stop sharing. And thank you all for listening and understanding. Pujita, hand over to you.
Sure. Thanks, Chandan. That was a very informative session. So it's 5:42 now. We'll take a quick 5 minutes break and then join back to hear from Tanmaya on secured containers. So we'll join back at 5:57. I'll just start a timer. Thank you. Welcome back, everyone. I hope everyone is back. Okay, so we'll move ahead in the event. Next, we have Tanmaya, who will be speaking to us on secured containers. So, hi, Tanmaya. Tanmaya is a thought worker with over 3.5 years of experience. Over to you.
Yeah, thank you, everyone. So, like Pujita mentioned already, I'm a thought worker, currently working as an application developer, and have more than 3.5 years of experience. The tech stacks which I have under my wrap is Ruby on Rails, JavaScript, obviously Dockers, Python, and yeah, this goes on, but that's not important. Yeah, let's get started. Okay. So yeah, here we start with container security. So the very first question comes that why did I choose this topic, container security? How is it important? So the reason for choosing this topic was that for a while, uh, uh, throughout I have working in applications, I have seen mostly people actually when it comes to the time of deployment, they use a containerized version to deploy either on some kind of server, whether it be QA, dev environment, UAT, or prod store. Or so basically, what I have seen is that people, although are aware of getting or are aware of how to build the containers and all, but somewhere they lack the deeper understanding that what can make their containers more secure. And why this is important is that if your container is not secure, so container security does not only mean that at the time what you are building has to be a secured one, but rather it's a complete shipping from your local environment to wherever you are pushing this image or wherever it's getting built. At each stage, it has to maintain a certain standards or a certain security practices so that your application does not compromise till the point of production. Because anywhere in this, from your local environment to your production, anywhere your application get compromised, the ultimate effect can be seen on the production environment or even before that. So that's something that I thought would be important to discuss with you all, and here I am with the talk. So yeah, let's get started. So the very first question that comes up is that before container security is why exactly do we need containers? So as you all be mostly working in Docker, I hope. Anyone here who is working currently or has worked in some other container build apart from Docker?
You can raise
Okay,
your hand, anyone.
okay, sure. No problem. Actually, most of the people actually use Docker only for the building their containers. So, what advantage do we get with Docker is that the basic tagline of Docker that build once and done it anywhere. So, the advantage that we get with the container is that we are sure that whatever application we are running, all the dependent application version or dependency, as we may say, has got the same version whenever it gets deployed to any environment. So let's say for my local, I have some uh, Docker file I build that. So if you can look through the logs while the Docker is being built, you might have seen that okay, whatever your application dependency is, it downloads all those things at the runtime. So you are sure that everything you need for running your application is right there inside that particular image, and nothing can be change at the runtime or should not be changed at the runtime. That's the whole point. That whatever your application needs, everything is there, and you can have a confident deployment across any environment. That okay, I have a consistent what do you say, shipping that of that application. So yeah, let's take one step back. So before when containers came up, so what typically what I know people used to do is they used to use VM machines, virtual machines basically. So the problem with virtual machine is that once you deploy your application over there or run your application over there, all the dependencies that is need would have to be taken at the time of starting the application, and you don't have that confidence that okay, all the dependency version. So let's take a case. uh, you might have got 3 different environments, but it's not using containers but rather using virtual machines. So maybe you can deploy your application directly to virtual machine, and you run it. So maybe whatever dependency application, it's dependency version of that application it's using might not be as the same as what you get after maybe say 2 days or 3 days when you deploy to some other machine. So that might create some problem, and that's also not good in the sense that since the dependency version is different, there might be some kind of error, or some kind of inconsistency that you may see. But here you get a consistency. That's the basic idea. So anyone, I'm free to have an open discussion. Anyone would like to suggest any good point why exactly do we need containers? Prithvi, Pujita, please.
Anyone
Okay,
would
please.
like to talk? Priya, you can pitch in if you feel it's the place.
Prithvi, I would like to hear you. Prithvi here? Yeah, we have Prithvi. Okay, fine. Let's move ahead. Um, okay. So now, as we are talking of security, there must be some basic definitions of them that we should be aware before we move on to the best practices, or what kind of threats do we face usually or in general. So this slide and upcoming slide would actually talk of more of a definition term. I know that it's not very practical, but still I would consider that knowing the definitions at least would help you in the real world. So basically, there are 4 things: risk, threats, mitigation, and threat modeling. So risk basically is a problem, and what if that problem occurs? So let's say it actually happened recently with one of our client projects. So we were using a Golang application, and there is a very famous library for which runs a server called as Ginger. So it actually had this issue, which we, open vulnerability issue, that using that library, the client can actually uh, spoof their IP address. So that was one thing. So that over there is a risk. Okay, this is library, is a risk. Now threat is a path to the risk occurring. Now how that risk comes to our application. So like for this case, when we say that the client can actually spoof into the host machine with their spoofing of ID, so that could be a potential threat. Now next is a mitigation. So mitigation is like, what do we do to counter that particular threat? Maybe you can like upgrade the version or use some alternate library like what we did, so to prevent the threat or at least reduce the area of that threat. Then next comes is threat modeling. So it's ultimately all the above 3 points comes to this one, threat modeling. That it's a process that how do we identify that the entire thing, that okay, if the risk is there, then what kind of precautions or measures we can take so as to either completely remove or lower the impact or significantly reduce the impact, so that our containers are much more secure or images are much more secure. So yeah, these were just terminologies. Now, when it comes to security principle, what we have seen is that we actually follow some, uh, you know, kind of privileges or mm, kind of terminology only, I could say, but that would actually help you to like uh, gain a much more confidence in terms of security. The first thing is that it's a least privilege. So this actually states that your container should only have that much access that it needs. Don't give them unnecessary access. For example, let's say you have an e-commerce application and you are running the multiple containers over there, okay, as a microservice, obviously. So let's say for one container, if that container, let's say, just needs to read some data from some database. Just give him the read access. Don't give him the write access also. It's not required at all. So the moment you define the privilege according to their need, keep it bare minimum, so the chances of getting attacked would be less and less. Then next is that defense depth. So basically, let's say you have multiple containers. Okay, if one of them gets compromised, okay, how do you make sure that okay rest of them does not get affected because of that? So that is actually taken care of by containers. As we all know that containers run in isolation completely. So even if let's say you have XYZ containers, container X got compromised due to some vulnerability issue or somehow. Now this affection, whatever is affected in container X, should not actually affect container Y and Z. That's the basic idea. And then reducing the surface attack, I find this one to be most important. So basically, always try to build your application in a simple manner. The more the complex the application is, that means the more number of libraries that you use, or more number of what do you say, open-ended points you are giving that can be used to compromise. In contrast, if your application is very very simple, like what we do in usual microservices, always keep small application in each of the containers. Now if your application itself is small, okay, the logic is simple, straightforward, it's you don't have a very big number of libraries or dependencies over there, fine. So the less the complex your application is, the lesser the chance that any attacker could find any um, you know open endpoint or some weakness points through which the attack can be leveraged. So yeah, that's the idea for this one. Any suggestions? Any thing audience would like to add?
Anyone? We can move ahead then.
And the third comes for security principle, limiting the blast radius and segregation of duties. So, like I said earlier, also that let's say your application is somehow the uh, you know attacker gets into your container, okay, via some means of vulnerable code or something. Now, if you have the container in a proper, you have not exposed any you know root file system onto that proper container. So it's a very it becomes hard for the attacker to like go get onto your host system or get outside the container somehow. But so that can only be achieved by like having you know taking proper measures while building the container, that okay, you are not exposing any root file system or any important file system of your host system, so that the external attacker, if gains access to your container, could go inside the host. Next is segregation duties. Like I said, that if we have small applications and that's divided across the microservices, even if one or two gets compromised due to some reason, we are sure that the entire flow of the entire end-to-end application does not get compromised, and that could actually mean that our application as a whole is not compromised, and that could come from segregation of duties. Threat modeling guidelines for continuous security. Yeah, well, we have the threat modeling guidelines for continuous container environments. So I'll be discussing that. That question was asked by Suman. Okay. Now container threat model. Okay. So when we say that we have threats, so what could be the uh, we need to identify first that who could be the potential actors that can act as a threat for our containers. Okay, one is obvious, the external attacker attempting to access a deployment from outside code. So how could this happen? That external attacker is trying to. So let's say your application is using some dependency, and that dependency has got some malicious code. Okay, or some kind of uh, undesired code that can actually allow the third party attacker to get inside your container, or even worse, run a some code inside your container. So that is the cause of external attacker. Then internal attackers are the ones, let's say within your organization there is someone who has got some access to some part of the deployment, but as, as I said previously, the access should be restricted as minimum as possible. But if someone has got minimum access already, okay, and is trying to go beyond their access level and trying to access some other container, so those people can be called as internet attackers. Then malicious internet attackers would be like developers, administrator, or someone, okay, which has the complete access level, and they are trying to run some kind of malicious code inside that. Then internet attackers is like someone is actually not with the intent of trying to run some malicious code, but the person is himself is unaware of that vulnerability, and runs it without unknowingly, basically. And last is the last and least, the application process, that while not sentient beings intended to compromise the system. So either application process can come in two ways. Either it's your own application code. So let's say you are opening some endpoint and you are not properly closing it, or maybe you have not maintained a proper security connection while talking to the outside world. So this might come as a application process. Okay, moving next. Fine. So here is what your system actually looks like when we have a container. So if you can see this gray area, it's a complete physical machine, and inside that we have a network. This network completely, this orange line that you can see, it wraps your virtual machine, and inside that you have another, again a container network, which inside which you have container and application. Fine. So how could the attack happen? So some of the possible points are that if you are having insecure networking for your physical machine, then let's say some kind of secret is exposed. So let's say you have a container where you actually passed some kind of secret text key or something while during the build uh, for your database password or some other kind of passwords. So that can actually potentially lead to the problem of security. Then you have compromised container image or badly configured container image. So let's give an example of compromised container image or badly configured container image. So badly configured container image is, let's say, I'll give you one scenario. I have built an image, okay, and that actually mounts the root file system of the host. So basically, whoever is on that, if some attacker gains an access to the inside the container somehow, okay, he can literally see everything on your host system. So that actually is a very good example of badly configured container image. Then you have vulnerable code exploits, like I said you already, that let's say your application is there, and it has got some vulnerability. So it can, if a proper setup is not done in terms of security, the attacker might gain an access to the host application or container runtime orchestrator, and can actually interrupt your normal flow, which is obviously undesired. Okay. Any questions to this point?
We don't have anything. We can move forward.
Okay. Now comes the container threat model. Okay. So the first thing is the vulnerable application code. So for any application code that we try to develop, its life starts with the developer who is writing that code. Okay. Now that code might have two optional, I mean, two vulnerabilities. One is that your application code itself, you are not taking properly the care of the code, or the dependency which you are using is not thoroughly checked and might use vulnerable code that could actually cause problem for your application. So yeah, the first point talks about that, and the second is like badly configured container images, the one which I just talked about. So when your container is actually being built, make sure that you are not exposing sensitive data, or uh, mounting a sensitive root path of your host system, because the moment you do so, and if the container gets compromised, literally your entire host system is actually uh, compromised. Then build machine attacks is that, usually what people follow is that once we have our uh, code ready, so we do a build on the pipeline, GitLab or some other kind of pipeline. So what happens if someone can gain access to that particular build machine, okay, and can influence the uh, outcome or the image build, because ultimately we won't be able to see that if we don't have a proper security at the build machine. So anyone who gains the access over there can modify the build image, and ultimately whatever we ship it to the production or other higher environments would be running a vulnerable code. And then comes the supply chain attacks. So yeah, this is a pretty famous one. So let's say uh, usually people have two preferences, like once your Docker image is built or some container image is built, it's like either shipped to a registry or to this Docker registry. By registry, the first one I mean a private registry that your company might host, or you might host individually. Okay, now just think that if your this registry which you are using actually gets compromised, okay, your image is built, everything is done, and the place where it's stored, that gets compromised, okay. So your application, okay, and usually people what they do is uh, ship the or push the image via some tag, okay. And tag is nothing, you can add to any kind of image after it's being built, that okay, this image is this with tag. So any kind of attacker, so any attacker who gains access to the registry can easily go over there, modify the image and add a new tag, and it would be hard for you anyone to figure out that okay, what is the actual cause for unintentional behavior or any kind of malicious code, even if it's there, to figure out that what's going wrong. So yeah, that's the thing. So I think I have few
Tanmay, we
questions.
have few questions. Yes.
Mhm.
One is on what is container escape?
Sorry, I cannot see the
What
question
is,
actually. One second.
yeah, I can read it out. What is container escape? Priya is asking.
So container escape is, let's say somehow the attacker gets into the container, okay, and can actually move out of the container to the higher environment, that is either VM or on the host system. So that's called SQL container escape. So we should make sure that whenever we are building that container, we should have proper security that the attacker could not move out of that system, or even lying by being inside that container, the attacker should not be able to access the host system, whether it be VM or direct OS. I hope that answers your question.
Yeah, I
Yeah.
did ask that. Do you mean it is about root operating system or an escalated privilege? What
Sorry.
I did ask if you mean it is about root operating system or an escalated privilege, which is getting targeted, and then you use the term container escape.
I'm sorry, I'm not able to hear properly.
Okay, that's okay.
You can repeat, maybe just once.
Okay,
Yeah,
sure, sure. One second. Where is
I got it. So I did ask that if you mean it is about the root operating system or an escalated privilege, the attacker is trying to get.
correct, correct, correct. Both can happen actually, right? Okay, next question, please.
Yeah, that is all we have now.
Two other questions also. Okay, no issues. Okay, I think I. Okay, I was here, right? Well, supply chain tax. Next is your container set models consists of badly configured containers, and then vulnerable hosts and exposed secrets. Okay, so uh, just a second, please. So yeah, the first point again coming back to badly configured containers. So like I already mentioned that you should not ever give unnecessary permissions. Okay, and one what a very common practice is that we usually download some kind of YAML configurations from the internet, and we actually don't give much importance to that configuration setting. So it should not be taken lightly. Always try to have a check on the configuration or whatever security settings you are applying on that container, because that might lead to some or the other vulnerability. Next contains again the vulnerable hosts. So that so let's say your container is running that you know uh, running on a particular host. Okay, now like I said that if containers, if you can keep your application small, okay, then it means that less number of dependencies, smaller the size of the image. Once we have that, in contrast to where we have a big chunk size of image and have got a lot of dependencies. So the more the number of dependencies we have, the more the number of chances that some kind of exploitation could be happening on your system. So always try to keep it as low as possible. Now one thing that you might ask is that let's say even if we have more number of applications, okay, so how does that affect if let's say I did some kind of already vulnerability checking on my system, that okay, it should not everything is passing in the terms of security, some kind of security mechanism you are using. Yes, you are right for the instance, yes, but that security checking is actually a continuous process. You have to check like the standard time period for doing that is like 1 or 2 days. For every 1 or 2 days, keep checking your application for more and more like rechecking that okay, whatever dependency you have, so that does not have any vulnerability. So yeah, we'll be coming to those at the last. And then is expose secrets. So any kind of credentials, token, password, whatever it is, you should never ever expose to a container, because even if let's say it's not from any external attacker, within your organization also, if someone can gain the access to your container, he or she should would be aware of that secrets, which should not be done. So let's say, take one example. So let's say I have some container where I actually copy some file which has got secret, and then in one line I actually have copied that, and in the next line I actually remove that. So ideally the people would think that okay, since I removed that, the container is not actually exposed to this secret, but that's not the case. So what happens is that when you actually build the container, uh, build the image basically, so every particular instruction that you write is one layer over the other layer. Okay, so if you can actually save your container in some .tgz format or something, okay, and inside that, if you go to that layer where you copied this, you can easily see that particular text or credential, password, or whatever sensitive data was there. So yeah, never ever try to give any secrets within your this thing container. Okay, moving on to next. Fine. Now, what are the potential problems that we see in uh, while building the Docker? What dangers could be there? Okay. So first is obviously the sensitive data in the layers. The last thing which I talked to you. So even if you have, if you think that you can use in some layer and in the other layer you can remove that, please don't do that, because it still remains in the history of that particular image, and any person who has got the access to the image could easily see that. Now next is that whenever we actually build some image, okay, then each of the image is actually stored as a blob of data in the registry. So take like this. So let's say I have got 5 different instructions in my particular uh, build file, and I build file 1, and I have got some other build file 2. Okay, now what happens is that when I build it, each layer has got its own blob of data, and let's say and the this thing, what do you say, image manifest or image layer that comes up, okay, for that particular image instruction layer would be actually stored as a image blob, and next time as a separate image blob, and the image manifest actually keeps track of those blobs. Now let's say in some other while building some other container, if you have the same instruction, okay, then that could actually use that one only, the previous blob, because the instructions are same, and hence the image blob would be same for both. So yeah, that's one thing. Now there comes a very important thing, that tags can be moved from image to image, and hence there is no guarantee that specifying image by tag today will give you exactly same result as it does tomorrow. So what does this mean? So whenever we build any image, we usually give it a tag, uh, either by commit number or tag v1 point something or anything, and push it to either Google Container Registry or some other private repository or something. Now, just think, anyone could actually build any other image and give the same tag. Okay, and when you download via tag, there is no guarantee that it would actually contain the same intended image that you were trying to push. So let me explain this further. So let's say you have pushed some code with a tag on the repository. Now in that repository, if attacker or some unintended player can get the access and try to change the code within that particular file and rebuild the file with the same tag. So ultimately, after some time, whenever you actually try to pull the image, you will be thinking that we have the same image, but the image is actually different. So what could be the potential counter block for this one? So one potential counter block for this one is that we can actually use an image hash. So basically, whenever we build some image, that image hash, the final layer of images, which calculates the layer by layer, every layer has a one hash, and it calculates based on the final thing. That okay, these are the layers. Now, when you push like this, what happens is that since this one is calculated from the you know during the Docker build process. So the advantage you get over here is that someone, even if the attacker gains an access to the your repository or your container or repository or your any place where you are actually pushed, he would not be able to manipulate that. At max, the person would be able to delete that, nothing more than that. And even if the attacker has those permission to remove the things, but this again advantage comes with a little bit defect. So usually whenever we build a Docker image, what we do is we use some Docker hub or some official image. Okay, when we say that we are going to use the hash of that image, so what will happen is that, let's say I was having some image which was using Alpine, let's say Alpine 3.13 was the tag basically. Now, since I am not using the tag anymore and I am using the hash, that's perfect. I will get the same image. But the downside is that for that image, Alpine 3.13, if let's say today or tomorrow, the developers, whoever are like, optimizing the code or actually giving out a new, uh, doing some bug fix or something. Okay, so there will be one more image hash on the top of that particular tag. Okay, and since you are actually downloading by using the hash thing, you won't be able to get that thing, the new latest whatever is defined for Alpine 3.13 or whatever base image you are using. So yeah, that's it for this second and third and fourth point. I see we have some questions. So
No, Tanmaya, we don't have any.
sure, sure. So yeah, let's come to image security. So like I said, it's not just about building the image and running, making sure that you have built with the right access and all the vulnerabilities has been checked on your system, but rather it's a journey from your source code till the point on the target machine, whether it be the final production environment or any other previous environments. So over there, as you can see with this image, that there are couple of points where actually the attacker can gain access and try to do harm your particular or modify your particular code in order to either make your application run in an unintended manner or to gain some advantage on top of that. So by this image, the first thing is like source code. Wherever we push this, and then we push it to like the source code Git or whatever version control system we are using, then your source code itself could be tampered by someone, or even better, someone actually tampers with the Docker file. Then comes your CI/CD build machine. So attack on the deployment via the build machine, or you have your image, vulnerable base image. Now, what does that vulnerable base image means? So usually, whenever we try to uh, build some Docker image, we actually use from some image, right? Usually, it's a good practice to always use official images, but there are open other images also which are not official. So vulnerable base image could be mainly from those images which are not official, because ultimately you are not knowing that what is the code layer within that. So always try to use the official image of Docker Hub or any other repository hub from where you are using. Then next comes again the vulnerable dependencies and modifying images during the build. So these can be taken off at the build layer. Then next comes your registry, that like I said, that your stored images can be tampered with if you are using tags. Okay, so the giving having a good security at the registry level, wherever you are storing your uh, Docker images, is very must. And the last is that some kind of malicious deployment definition can be done at the time of deployment. So let's say you are trying to deploy something, and at the time of deployment, if the attacker has gained the access to the uh, this thing, the deployment machine, fine. Then whatever you are trying to mount, or whatever you're trying to access from your container to the host, that definition could be the environment variable thing or configuration can be changed, okay, to make your deployment fail ultimately. So yeah, these are the few things that can be taken care of for the image security. Okay, let's move next. Fine. Now, Docker files is the best practices for security. All now till now, whatever we discussed was the potential problem and where it could come from. What are the possible solutions? But let's now discuss what are best practices for security. So the first point is like refer to an image from a trusted registry. Like I said, always try to use the official images, because not only it's checked properly, but also if any bug is found in that one, it's a high chance that it will be taken care of by the other people using in that community, and you will get a fix as soon as possible. And also, when we have this security checking in the pipeline, I'm sure most of you have actually used that. So when we actually build some image, there are tools that actually scan your images for vulnerabilities. Okay, now if when you use any open source thing, okay, or verified image, so the chances of getting a known vulnerability is very very high as compared to some other image which might not be official, because the number of users itself are less, and also the number of uh, the guys who try to find the weakness or vulnerability in that particular image are less. So yeah, always keep in mind that try to use this thing. The second thing is that arbitrary third-based images might include malicious code. Yeah, never ever try to use any malicious code until and unless you are very, very confident that okay, this particular code which I'm using does not have anything malicious. And even in some organizations, they have already set up that okay, even among the official images, these are the only permitted images that you can use for the build. So that's one thing. Next is again, the smaller the base image, the less likely that it includes unnecessary code. So what happens is that while building a particular image, okay, it might be that you need a number of tools to build that particular image, but that is not required for your applications to run. So one good way of making the base image small is to use multi-stage building. So let's say you have two different images. The first image actually installs all the dependencies and all, and let's say you have a Golang application, for instance, and Golang application gives you an executable at the end. So simply install in the first image, install the Go compiler and whatever is required for downloading the dependency and making a build of that particular application. And then in the second application, simply copy that executable from the first application to the second application. In that manner, your image size is also small. And think logically, ultimately your aim is that your final build image should run your application. Let's say in the scope of Golang image, Golang application, sorry. So now when you have that, you don't need the Go compiler in that your final image. So always try to keep it minimal uh, as much as possible. So yeah, and the third thing is that though it's not very much with reference to security, but think like this: if you have smaller image, not only the chances of getting attacked is small, but also when you publish the code, or sorry, when you publish that particular build to some repository or the uh, since your image size is small, as keep it as small as possible, so that over network it takes less time to share that. And this one is again what I have highlighted in bold is be thoughtful about using tag or digest to reference the base image. So yeah, both is okay, but if you use digest, then you miss out the chances of getting the updates for that image. If some kind of vulnerability found, how do you get that? But if you use tag, then again the chances is that someone might actually change that code and uh, give you some other code or image other than what you intended. So yeah, anything till here? Any questions? Any feedback?
I don't think we have any. If any one of you have questions, let me know. I'll unmute you.
Sure, sure, no issues. So moving on to the next Docker best practice file is one thing is that always use multi-stage build. It's way to like eliminate unnecessary dependencies that your application might need, and you in the final stage where you actually ship your final image, you get only those things which are required. Okay, and like I've been speaking from the beginning, the smaller the size of the image, that means the less the number of dependencies is there, and the less the number of dependency, the less the chance is there that some vulnerability will be exposed as compared to the more number of dependencies is there. Then one more thing that we get advantage from. So okay, just one thing before I move forward. How many of you have actually used multi-stage builds previously, or are using build kit for building a Docker file? Anyone?
You can talk in if it's your name. Sorry.
Sure. So the next thing is that volume mounting. So uh, we often so it might be the case that you have got some application on your host system which you want to always mount to your container. Okay, so that in the runtime, whatever containers, let's say, try to you know change something or write something, fine. Then you can actually use volume mount, but be careful with that, not to mount sensitive data like slash etc slash bin or directly the root container itself. So in that fashion, you are making sure that okay, uh, unnecessary uh, file system is not getting mounted on the containers. Also, while mounting, you can actually give an option of read only or read write. So usually what we do is docker and hyphen v, then the path to the host, and then colon path to the container where you are expecting things. And if you want to reduce that, you can do one thing after the path to host or path to container. You can actually give colon arrow or colon rw. So colon arrow will actually make it read only, whereas colon rw gives you read and write access both. So that's one way to give your mounted uh, file system a read only access, so that any person from the inside cannot actually change something on the host system. Okay. Next is your drift prevention. Drift prevention is that whenever we actually try to build some image, okay, it might be possible that at the runtime that particular image or container actually tries to download something at the runtime, but that should not happen. Because if that happens, there are two things. One, the very idea of container actually gets violated. The idea of container was that wherever you have whatever dependency you have, you ship it all together and uh, push it, or deploy that on any environment. You have a consistent environment. Now think that if your application that you are building and you are deploying at three places, and that's downloading the some kind of tool at the runtime. Okay, so that might mean that different instances of your containers are actually, for the same image, for the same underlying image, are actually using different versions of the dependent applications or some application that you're downloading. So that should never be done. And also that if you are doing this, you also have a security issue, that let's say before deploying, you usually have a image scan check, right? That okay, while there are some open tools like Travis or Clear Analysis that actually does the checking of that particular image, that whatever dependency is there, it has not got any vulnerability or such a thing. But if you are doing this drift thing, then at the runtime you are actually downloading thing, okay, in your container, and that is not scanned at all. So that is actually a bad practice in itself, not only from the point of view of security, but also from the point of view of containers itself. And there are actually open tools that could actually allow you to you know have drift prevention, that your application at the runtime cannot try to download something or make changes itself. There are actually tools available for that, and that is called as a drift prevention. Okay. Now even if, let's say, I have treated my containers as immutable, let's say I apply those tools and I have some strict mechanism that okay, at the runtime no other application will be downloaded, still my application is not very much secure. Reason being, let's say I deploy some application today itself, okay, and it passed all the analysis. Now what happens if one of those dependencies that my application is using has got a vulnerability 2 days later? My application is already deployed on production or some other environment, and that's compromised. Now I know after I have deployed. So to maintain that, what we can do is have a regular scanning every 24 hours or every 2 or 3 days, so to make sure that okay, whatever is deployed currently does not have any vulnerability. So yeah, that's the thing of this one. Any questions still here?
Not a question. There is a request which says, can you share more insights on private registries?
Private registries are actually maintained via the companies actually. Okay, so it's nothing new. So see, we have already Docker registry, right? So whenever you can actually create your own Docker account and you can push your code over there. Similar fashion, what usually companies do is that instead of pushing it to Docker registry, they can create their own instance and host it somewhere on their system. So let's say you must have heard of that. There are actually instances of GitLab running for their own company. Okay, it's not the open source GitLab that we actually use as a user, but their own instance. Similarly, you can actually try to build your own private registry and have whitelisting checking and all that anywhere from the outside person cannot access. Only limited whitelist APIs can actually access those repositories. So yeah, that's the idea basically. That's the general idea.
My question was more on the security aspect of private registries.
Mhm.
What what should be the
Ye-
best practice to host one and then
Yeah, see,
maintain that?
understood. Yeah, understood. So basically, one thing that you can do is always have a whitelisting IPs that okay, only these IPs okay can access your registry. Number one. Number two, even if your whitelisting IP is there, you can always have some kind of access token that can actually read from that particular registry. So let's say you have your own instance of some source code maintaining. Okay, let's take example GitLab. Okay, so over there you might have seen users getting the read access, write access, or read repository, something like that. So you can always grant them with access token that those people with these access token can actually access those registries. So it's more of what you was asking from the infrastructure point of view.
Yeah,
Does that answer
and
your question?
that service as well. Just because now I am not just using the Docker container or the image, but I'm hosting them as
Okay, sure. Okay. Any other question? Fine. I'll move
Uh,
next.
there is a question from Suman which says, can the drift prevention policy in cloud environment? Suman, maybe you can talk. You can describe your question better.
Yeah, sure. Yeah, am I audible?
Yeah.
Yes, yes, you are.
Okay, okay. You just mentioned the drift prevention and the tools available to prevent the drift prevention. So, is that plausible in a cloud environment?
Yeah, it's possible. There are open source tool available for that. Okay. Just you can search for them, and that actually takes care of that. That your
Oh,
image at the runtime cannot be manipulated.
okay, okay. I mean that the tool to be deployed in the cloud or separately.
No, that has to be deployed in the cloud. That
Okay,
has to be there.
thanks, thanks.
Yeah, sure. Okay, so I hope that till now I have made some sense. Now we come to the last part of the slide. No, 1 second. One thing left. Okay, so yeah, before just quitting, I would like to give some scanning tools like Trivi, Claire, Anchor. These are the actually tools that you can actually integrate with your CI/CD pipeline, and whatever dependency each time your application code gets pushed, okay, in the pipeline, that pipeline automatically builds the that particular instance of application and tries to scan the image for any vulnerability basically. So how this works is that, like I told you in the beginning, that each layer has got a hash defined. Okay, now there is something called as national vulnerability data that is maintained by CNCF, Cloud Native Computing Foundation. Okay, now over there, when you actually build your image, each of the layer has got a hash, and that hash can be actually broken up into the libraries, that is the dependency name of the dependency and the version that it uses, and that is exactly what is sent to the database and checked over there, that okay, with this dependency and this version, do we have any kind of vulnerability? If it's there, then you are reported, otherwise it's safely passed. So that's the idea. And apart from there, you have actually other configuration tools also. So like you can use network configuration tool, identity access management tools, user defined policy tools, and open source tools. So open source tools is the one that we actually use for mostly scanning your image and giving out the open source vulnerable codes. So like I gave you example in the beginning itself, we faced the issue with Ginjanic. That's a famous library in Go. So that's one thing. Then let's say in user defined policy tools, you can actually enforce some constraints on your containers, that uh, this the whatever that container, if it's run at the runtime, should not do these activities, or has got this some kind of security policy that it cannot override at that time. Then identity access management tools is like having a complete access of all your resources and important security measure that you can take. So uh, basically this takes care of like roles and responsibilities that should be taken care of during the Docker container build. And there are also tools that facilitate this. So one of the famous tools is Notary, but the problem with Notary is that it's not very beginner friendly. You have to have a very good knowledge of this one in order to work with. So yeah, and the last one is that network computation tools. It always identifies that if your application in some manner is talking to the outside world, then is it like properly following all the security principles, uh, and it's not vulnerable from outside to your so that any attacker could get inside your container or to damage your container. So yeah, that's it. What I think. Any kind of suggestions, feedback is welcome.
Yeah. Anyone wants to talk, or do any one of you have questions? Yeah,
Okay.
I think we are good then.
Sure. I just hope that my entire slide actually gave some knowledge or insights about secure containers. Please feel free to share
Yes,
feedback.
yes. Thanks, Tanmay. Thank you for very good insights on the security of the containers. It was very informative. Uh, with this, we come to the end of the event. Thanks, Tanmay and Chandan, for such great sessions, and thanks to attendees and organizers. We'll all see you in the next Geek Night for edition 2. Thanks, everyone. Have a good night.